Here we will be talking about the double angle and half angle identities. So here, let's first start off with the double angle. So here are the formulas that were given to you. So there, I just basically copy pasted them from this guy. And now we're gonna just go ahead and just do a problem. So suppose that cosine of x is equal to 4 over 5 and cosecant of x is less than 0. Find the exact value of sine 2x and cosine 2x. So a couple of things to just know is that we can see cosine of x is positive. So if you remember that this is going to be all students take calculus, they tell me where everything is positive. You now see that this can either be in quadrant 1 or in quadrant 4. So which one do we would decide? Well, we have to look at the other piece of information that they give us. So they also give you that cosecant of x is negative. It's less than 0. So this means that it's negative. So that means that this must be in quadrant 4. Okay, so we're going to go ahead and draw this out. So this thing is going to be now in quadrant 4. So our triangle is going to look like that. And here is x, the angle x. So now we know that cosine is going to be adjacent over hypotenuse. We can figure out the other guy very easily. So this is going to be 4 squared plus b squared equals c squared. So b squared is going to give me, what is this going to be? It's just going to give me 9. So b equals 3. Now, it's a positive or negative. In this case, it's going to be negative because it's in the negative y-axis, so this is going to be negative 3. So now all we need to figure out is what sine 2x and cosine 2x is going to be. So let's start off with first sine 2x. So the sine of 2x, so if you go back up, the formula is just 2 sine cosine, just 2 sine x cosine x. So 2 sine x in this case is going to be the opposite over the hypotenuse. That's going to be negative 3 over 5. And then the cosine is going to be the adjacent over the hypotenuse. That's going to be 4 over 5. So it's going to give me 2 times negative 12 over 25, which is going to give me negative 24 over 25. So that's going to be my answer. Okay, now let's figure out what cosine of 2x is going to be. Now here we can choose whichever we want, any of these formulas that we want. I'm just going to go ahead and just choose the first one, cosine squared theta minus sine squared theta. So cosine squared x minus sine squared x. Now remember that whenever you see a squared like this, you can always rewrite it as cosine x squared minus sine of x squared. So the x is not squared, it's just the whole thing is squared. So cosine of x in this case is just going to be 4/5 squared minus sine of x in this case is going to be equal to negative 3/5 squared. So this is going to give me 16 over 25. That's going to give me, forget the squared, minus 9 over 25. Okay, so this one was 4/5, just making sure. This one was negative 3/5. Okay, good, perfect. Okay, so now we're going to take 16, and then we're going to subtract it by 9. And now we're going to just get 7 over 25. Okay, and that would be cosine of 2x. Okay, obviously we didn't ask for tangent, but if we wanted to find tangent, we could have used this formula if we wanted to. Or if not, we could have just divided the sine over the cosine. That would have also given me the tangent. So just like before, here are the half angle identities. So I just wrote them down. And what we're going to do is we're going to do an example. So one of the things to just take into consideration is this. Oh, I forgot the equal sign here. Okay, so then it's a plus or minus. So this plus or minus will depend on where alpha over 2 is, or theta over 2, or gamma over 2, or whatever this angle is. Wherever this guy lies, that will tell me where this plus or minus is going to be at. Okay, so now here's the problem. So suppose that tangent of beta is equal to 3/2, and beta is between pi and 3 pi over 2. So find sine beta over 2 and cosine beta over 2. Okay, so now what we want to do is let's first find out where exactly beta is. So right now beta, if we look, is going to be in the interval pi and 3 pi over 2. So when we draw the triangle, it'll look something like this. All right, and we know that tangent of beta is 3 over 2. So this is going to be 3. So it's going to be the opposite over the over the adjacent. Now be careful because this is quadrant 3. That means tangent is positive here. That means both of these guys are negative because you're in the negative x-axis and then the negative y-axis. And notice that this actually doesn't make any errors because then the negatives are just going to cancel each other out. And then we can just use the hypotenuse, so by using the Pythagorean theorem. So you have 9 plus 4 equals c squared. And then we're just going to get 13. So notice the hypotenuse is always going to be positive. So this is going to be square root of 13. All right, now all we have to figure out now is figure out what the sine of beta over 2 is. So sine beta over 2 is going to be equal to the plus or minus square root of 1 minus cosine of beta over 2. Okay? So that was correct, right? I just put in the beta. All right, so now how do I know whether this is going to be positive or negative? Okay, well, let's figure that out in a little bit. Let's just plug everything in. So we got to do 1 minus cosine of beta. So cosine of beta is going to be the adjacent over the hypotenuse. That's going to be negative 2 over square root of 13 divided by 2. Okay, so this is going to give me plus or minus square root 1 plus 2 over square root of 13 over 2. I can now make this a little bit nicer. So this is going to be plus or minus square root. So there's going to be square root of 13 over here, square root of 13 here, plus 2 over square root of 13 over 2. So you're going to get plus or minus square root of the square root of 13 plus 2 over square root of 13 over 2. So then your answer will finally be the square root of 13 plus 2 divided by, the 2 is just on the bottom, so it will be 2 square root of 13. Okay, so this looks really, really messy. Okay, so now the only thing that we have to figure out is where exactly is it? Is it, because it's plus or minus, remember that we're looking at beta over 2, not beta. So if you look at beta, beta right now is between pi and 3 pi over 2. Now what we want is beta over 2. So how do I get beta over 2? Well, we get beta over 2 by dividing everything by 2. So I'm going to divide this guy by 2, and I'm going to divide this guy by 2. So you're going to get pi over 2, beta over 2, and then 3 pi over 4. Pi over 2 is right here, and 3 pi over 4 is right here. So it's in here. Beta over 2 lies in here, which means that it's in quadrant 2. So in quadrant 2, you have to think about what is the sign. The sign in quadrant 2 is positive. So this guy is going to be positive square root of 13 plus 2 over 2 square root of 13. Okay, so that guy is going to be positive. Okay. Now let's look. So now that I know that beta over 2 is in quadrant 2, it's going to be easy to figure out the next one. So cosine of beta over 2, that's just going to be equal to the plus or minus square root of 1 plus cosine beta over 2. So I'm going to get 1 plus, this is going to be a negative 2 square root of 13 divided by 2. So now what I'm going to get is the plus or minus square root of 1 minus 2 over square root of 13 over 2. And now let's go ahead and just combine these things. So square root of 13 over square root of 13 minus 2 square root of 13 divided by 2. So now what you're going to do is you're going to take square root of 13 minus 2 over square root of 13. Divided by 2. Get plus or minus square root of 13 minus 2 divided by 2 square root of 13. Now since cosine is in quadrant 2, it's going to be negative. So the answer is going to be negative square root of 13 minus 2 over 2 square root of 13. Okay, and that will be my final answer. So it's really, really messy. The numbers when you're dealing with beta, with the half angles, especially if when you do the triangles, if they're not nice, you're gonna wind up with some weird answers like this. But this is usually the answer that I want. I want exact answers.